Examples of Pythagoras theorem. Let us take an example. P and Q are points on the sides CA and CB respectively of a triangle ABC, right angled at C. Prove that AQ square plus BP square is equal to AB square plus PQ square. Let's see the solution. Given a triangle ABC in which angle ACB is equal to 90 degrees and P and Q are any points on AC and BC respectively, AQ, BP and PQ are joined. We have to prove that AQ square plus BP square is equal to AB square plus PQ square. Let's see the proof. In triangle ACQ, angle ACQ is equal to 90 degrees, so by Pythagoras theorem, AQ square is equal to AC square plus CQ square. Call this first. Similarly, in triangle PCB, angle PCB is equal to 90 degrees. Once again by Pythagoras theorem, PB square is equal to PC square plus BC square. Call this second. Adding 1 and 2, we get AQ square plus PB square will be equal to AC square plus CQ square plus PC square plus BC square. Now in triangle ACB, angle ACB is equal to 90 degrees. Therefore, by Pythagoras theorem, AB square is equal to AC square plus BC square. Call this fourth. In right triangle PCQ, PQ square is equal to PC square plus CQ square. Call this fifth. Adding fourth and fifth, we get AB square plus PQ square is equal to AC square plus BC square plus PC square plus CQ square. Now we can compare third and fourth and we can see in both the equation the right hand sides are the same. So the left hand sides become equal. So we get AQ square plus PB square is equal to AB square plus PQ square, hence proved. Let's take the next example. In the figure, triangle ABC is an obtuse triangle, obtuse angled at B. If AD is perpendicular to CB, prove that AC square is equal to AB square plus BC square plus twice BC into BD. Let's see the solution. Triangle ADB is a right triangle right angled at point D. Therefore, by Pythagoras theorem, we will have AB square is equal to AD square plus DB square. Call this first. Now triangle ADC is also a right angled triangle, right angled at point D. Therefore, again by Pythagoras theorem, AC square is equal to AD square plus DC square. This implies AC square is equal to AD square plus, in place of DC we can write DB plus BC whole square. This implies AC square is equal to AD square, applying the formula of A plus B whole square, plus DB square plus BC square plus twice BC into BD. This implies AC square is equal to combining AD square and DB square plus BC square plus twice BC into BD. This implies AC square is equal to, from first we have AD square plus DB square is equal to AB square. So in place of AD square plus DB square we can write AB square plus BC square plus twice BC into BD. Let's take the next example. In triangle PQR, QM is perpendicular to PR and PR square minus PQ square is equal to QR square. Prove that QM square is equal to PM into MR. Let's solve this. In triangle PQR, it is given that PR square minus PQ square is equal to QR square. This implies Taking PQ square to the other side, PR square is equal to PQ square plus QR square. This implies, by converse of Pythagoras theorem, triangle PQR is right-angled triangle right-angled at point Q. This implies angle 2 plus 3 is equal to 90 degrees. Also, angle 1 plus 2 is equal to 90 degrees because angle PMQ is equal to 90 degrees. Comparing the above two statements, we can say that angle 1 is equal to 3. Similarly, we can say angle 2 is equal to angle 4. Thus, in triangle PMQ and triangle QMR, angle 1 is equal to angle 3, angle 2 is equal to angle 4. Therefore, by AA similarity, triangle PMQ is similar to triangle QMR. This implies PM by QM is equal to MQ by MR. On cross multiplication, we get QM square is equal to PM into MR.